Hi, I'm Jens. I'm an engineer here at AGI, and today I'm going to show you force model vectors. Did you ever need to know or want to know what forces act on your satellite due to various perturbations, drag, SRP? How much forces do you get from the moon or Venus? Well, there's a force model vector that gives you exactly that. Let me show you how to do it. So I'm going to create a new vector on this. It's just basically the default LEO satellite. Create a new vector. And one of the types is force model. So this is the GUI is very similar to what you get in HPOP. So you can specify what forces you want to account for. In this example, I'm just going to use drag. So I'm going to turn off gravity. I'm going to turn off the moon and the sun as your third body perturbation. Here's your drag. I'm just going to go with the default. So here's your drag coefficient, spherical model, the Jakia-Roberts model, and just a default value. I'm also going to turn off SRP, the solar radiation pressure, and give this a meaningful name, drag only. So, if you want to know how much drag is your satellite experiencing, what's the forces of the moon, you can easily create a vector that does that. So here's my drag only vector. So now let me report that out and see what values we get. I'm going to create a new report style. And under vectors, I'm just going to go with the body frame. Here is our new drag only vectors. I only care about the magnitude for now. So time, magnitude, since it's in the anti-velocity vector. OK, and report that. So the default units in kilometer per second are probably not ideal. So let me change that to meters. And we're getting there. I'm going to change the number of significant digits to, let me just double it. So here is the acceleration you get from just drag on my satellite. If you want the forces, just use F equals ma. Here's our A. We know the mass, or you hopefully know the mass of your satellite, and you can get the forces. So you can do various analysis. Should your drag model or your propagator account for for example Venus, if Venus is very close to the Earth. So you can compute the magnitude of that vector and see if it's worth accounting for. All right. Hope you learned something new today.